Well, hi, I'm Jay Arthur, author of Lean Six Sigma Demystified and the QI Macros. I want to talk to you about what I call the next decimal place. Because I've been in the software business, people would make things and try and change formulas. So let's say it's CP and CPK. Well, you used to do the upper spec minus the lower spec over 6 standard deviations for CP. And guess what? Well, that would give you one reading, right? But then you started using estimated, right, standard deviation, right, using the variance between samples and so something like that. And that'll give you CPK. The other one gave you PP and PPK using standard deviations. And then about, 4 or 5 years ago, Minitab started using pooled standard deviation to calculate these things. Well, the funny thing about it is when you change from an estimated standard deviation using R bar or something like that, or S bar over C4, whatever happens, then you change to a pooled standard deviation. Instead of like 1.33 for a CP, you get maybe 1.333 or 1.335 or 1.326, right? It's the thousandth decimal place that gets changed. The 1.33 does not change radically. And so what are we doing? We're making things more complex, but are we getting more value for the last decimal place, the next decimal place? And although that's more statistically correct, if you're at 1.33, you're kind of at the floor of manufacturing quality, right? You need 1.66 or 2.0 for a Six Sigma level process to minimize defects and returns and all the other stuff and associated costs with it. So that last decimal place does not matter, right? You're trying to use an electron microscope instead of micrometer, instead of just a plain old micrometer or yardstick. Most people need a yardstick. So I want you to be cautious when you hear people, saying, well, blah, 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 blah. We use this special thingy-bob that you can't calculate yourself because it's too damn complex, right? Well, why are we doing that? Well, we're trying to stop you from being able to do these things. Yes, I understand. However, it's not going to change your end result. If you're at 1.33, and 1.335 is not going to make you look better, you're still too close to the floor for manufacturing quality. So just be cautious, okay? The answer, is it good enough? Now, if I'm sending rockets into space and trying to hit Mars, sure, I need like 12,000 decimal places. But for the average business, you do not. So I'm Jay Arthur. That's my improvement insight for this week. Watch out for the next decimal place.